In this lesson, we learn about the refraction and opacity section of the Coronamaterial. We'll be working with this new scene. We have this glass and bottle objects and few gems that are hidden for the time being. They are hidden gems. Create and assign a new Coronamaterial to these objects. And load the material in the node material editor and start the interactive rendering. Most of the refractive and transparent materials have a very dark diffuse color or no diffuse contribution at all, so I'm going to uncheck the diffuse contribution for this material. If you take a look at a piece of glass, you would notice very strong reflection. So enable reflections and make sure reflection level is set to 100% and set the reflection glossiness to something like 0.95. Now we are ready to start working on the refraction section. So enable refraction in the basic tab of the Coronamaterial. First, we have refraction level, which controls the amount of the refraction. When set to 0, we are not going to get any refraction, and when we gradually increase it towards 100%, we see more and more transmissive properties being added to our material. And at 100%, we have a fully refractive material. Then we have the refraction color, which is normally white, but you can use another color to get a uniform colored glass, which does not take into consideration the thin or thickness of the geometry and gives us this single constant color all over the object. I'm gonna change it to white for now. To create realistic colored glass, you need to enable the volumetrics and SSS section and use the absorption color and distance. So I'm gonna use this green color with the RGB values of 17, 181 and 148 as our absorption color. And now if we start increasing the distance to more than 0, we start to get this color on our glass. At lower distances, we see a very strong saturated color, and as we increase the distance to something like 10 or 15 centimeters, we start to see how the thicker parts are getting a more saturated version of that color, and the thinner parts are just getting a hint of that defined color, and that is how colored glass appear in real world. But still, for certain types of colored glass that have a more uniform distribution of color tones, you can use the refraction color itself instead of the absorption color and distance. For now, let's set the absorption distance to 0 and absorption color to black, and make sure the refraction color is white. Next, we have refraction glossiness, which controls how sharp or blurry the refractions are going to be. At 1, we get sharp refractions, and as I decrease the number, we get blurrier and blurrier refractions. For now, set the refraction glossiness to 0.8. One important point when dealing with blurry refractions is the fact that you need to also make the reflections blurry, or you would get very odd results because you would have sharp reflections on top of blurry refractions. So let's decrease the reflection glossiness to 0.8 as well and see what we get. Nice. Now we have a nice frosty gloss shader. Like other parameters, we can control refraction glossiness with a map. In this case, let's load this floral01.png as the refraction glossiness map. To see how the map is placed on the geometry, temporarily disable the refraction and reflection. And we can obviously connect this map, enable diffuse and connect it to the diffuse map to see how the map is being placed on the geometry. You notice the map doesn't set quite nicely on the geometry because of UV issues. So I'm gonna use a node called Corona Triplanar to solve that issue. So load the Corona Triplanar from the Corona textures. Simply connect the floral image to the x-axis input of the triplanar and connect the output of the triplanar to the diffuse color. What triplanar does is basically it projects the defined map from all the 6 sides, and it's such a useful map which we will be discussing later on in its own specific lesson. I'm gonna set the size to 25 centimeters so the map just gets a bit smaller, and blend them out to something like 0.5, 0.15 would be better. Now let's disable diffuse and enable reflection and refraction and connect the triplanar to the refraction glossiness. And as you can see now, we have this floral pattern controlling our refraction glossiness. Now clear out the map and set the reflection and refraction glossiness to 1. Next we have IOR, or index of refraction, which controls how much light is bent or refracted when entering a material. For vacuum, this number is 1, so that means the speed of light is not going to change in vacuum, obviously. For water, the number is 1.33, and that means light travels 1.33 times faster in vacuum compared to water. For most household glasses, it's something like 1.52. For diamond, it's 2.4. And you can visually see the changes and how the image behind the glass gets more distorted and more bent as I'm increasing the IOR value. And always remember to put the exact same IOR value in the Fresnel IOR field as well. For water, you would use 1.33 as the IOR value, and as well for the Fresnel IOR value in the reflection section. Let's set it to 1.52 for now. Next we have dispersion parameters. For these, let's hide the glass and the bottle and unhide the gems and assign the material to them. We can enable and disable dispersion effect, and then using this AB number control how strong the dispersion should be. The lower the AB number, the stronger the dispersion effect is. You should use values between 10 to 15. In most cases, you really don't need to go beyond or below that range. Notice how as I use higher AB number, the dispersion effect becomes less obvious. Let's set it to 10 and see what we get. And here is our strong dispersion effect. Let's disable dispersion, hide the gems, and unhide the glass and the bottle. Then we have this thin no refraction checkbox, which if enabled simulates a thin glass plane with no refraction and no caustics. And you should use this parameter when you have a single plane as your window geometry, and it can make interior renders much faster when a glass material with this option checked is assigned to this to that particular window. Then there is this caustics checkbox to enable realistic and physically accurate caustics. You just need a very bright and small light source to get caustics in Corona, but it really isn't optimized and it can be very, very slow. So I suggest to forget caustics for now until it gets further developed. Let's disable caustics and take a quick look at the opacity section. For now, let's disable refraction and reflection and enable diffuse and make sure the diffuse is being controlled with the default color for now. And enable opacity from the basic tab as well. Opacity is making the objects less or more opaque. It's not like refraction, it just makes the surface more or less transparent. When opacity is set to 100%, we get a fully opaque object, and when it's set to 0, the object becomes completely transparent. And higher values than 0 will make the object more and more opaque as we get closer to 100%. Also, you can use a map to control the opacity level. Let's connect the same floral pattern to the opacity maps as well. And now where the map is white, we get an opaque surface, and where it's black, we get a transparent surface. We also have this clip checkbox that will clip the defined opacity map to 100% black and 100% white values only, and any smooth gradients while used between black and white will be ignored. Okay, in this lesson we learned about the refraction and opacity section of the Coronamaterial. See you in the next lesson.